Continuing on with yesterday's leading cert, paper 2, maths paper 2, 2022. Question 3. So circle is the equation this, the radius of C is 5 root 3, find the value of K. Okay, that seems fairly straightforward. Okay, so let's see what we got here. X squared plus y squared minus 2x plus 8y plus k equals 0. The radius is, what is it? 5 root 3, yeah. Find the value of k. So just compare it to the general form. We should be able to get everything here. Plus 2gx plus 2fy plus c is equal to nothing. So, so the center minus g minus f is equal to 1 minus 4. The radius is equal to the square root of g squared plus f squared minus c. So that's equal to the square root of 1 plus 16 minus k. And that's equal to 5 root 3, yeah? Yeah. So, square both sides, and you get 17 minus k is equal to 25 by 3, which is 75. So k is equal to 17 minus 75. K is 58, is it? Yeah. K is 58. Does that make sense? Yeah. Okay, that's fairly straightforward. I need the method, and hopefully the number is okay. A circle has a tangent at the point 9 minus 4. Okay. So, circle, this is pretty okay as well by the looks of it. Plus y plus 2 squared equals 20. Okay, and a tangent at 9 minus 4. Find the slope. Slope of the tangent. Well, quick sketch. And so a tangent, by its nature, is it has to be perpendicular to the line from the center to that point, which is on, it's at that point. Great, so there's no extra working out to be done. It's 9 minus 4, great. So that is perpendicular. So really all we need to do to find the slope of that tangent is to find the slope of this, and then just use the equation m1, m2 is equal to minus 1. Okay, so let's get the slope of that line. So what's the center? The center is just from here. The center is 5 minus 2. Okay, so slope of the center to that line B, or that point B, is equal to, well, y2 minus y1 over x2 minus x1. Okay, so it's minus 4 minus minus 2, so it's plus 2 over, am I right? I am. Okay, I'm right. Why was I panicking there? Right, okay, so minus 2 over 4. So the slope is equal to minus a half. So the slope of the other one must be 2, because m1, m2 must be equal to minus 2. Okay, so that's the slope. That's quite straightforward now. That circle question. Now, says he, not knowing if I've actually got the number right. But then, as I keep saying, it's not vital to get the number right, as long as you have the method, okay? Alright, 2 circles. And this is kind of a familiar one. They love these. particularly touching at a point. But two circles each have the x-axis and y-axis as tangents. So basically they're circles which are bounded by the x and y-axis, and there's an infinite number of those really. So spreading out, it's just the radius there that varies, and their common point is 1 minus 8. Find the equation of each of the circles. Okay, so that's a nice one. Let's have a look. All right, well, sketch of this. Now, I suppose the thing to consider here is that they're bounded, so they just have one point, they're just touching the x and y axis. So that means that its radius of any of these circles is, well, if the radius is, say, a, then the center is AA. Well, minus AA in this case. Let me think about that. It's A minus A. Yeah, so it's A minus A because it is in the fourth quadrant. Okay, so the center is A minus A. Okay, and there's an infinite number of circles that would satisfy that would touch that. So there's a bigger one out here, and that center might be B minus B and so on. And the radius of the circle and the center are kind of linked, so it's kind of easy equations. So the equation of that circle there with the center A minus A is x minus A squared plus y plus A squared is equal to A squared. All right. Now, the common point is 1 minus 8. So really that's the equation of all circles with just different varying radii. So all that's varying in that circle is the radii, really, and everything is just dependent on one variable, and that's the radius, because the center then moves accordingly. Okay, so the common point is that, so plug her in. So we get 1 minus A squared plus minus 8 plus A squared is equal to A squared. So let's multiply that out. 1 minus 2A plus A squared plus 64 minus 16A, yeah? Yes, plus A squared equals A squared. Well, those two will cancel anyway straight away. Okay, and then what have we left? Well, we've 1A squared. How many A's, vanilla A's? Minus 18A. And then we have, okay, what else is left over? 65, yeah? Plus 65 is nothing. So that is now the general equation of all circles, and there may only be two, but it's all, so that's the general equation of all circles that touch the x and y axis there. And this is now the general equation of all of those which have that point in common. And it looks like there will only be two, because it's a quadratic equation, but let's have a look. Well, there'll be at most two. Okay, so 65, what is 65? Is that 15 by 3? It is, yeah. Okay, so our roots are minus 15, A minus 3 equals 0. So A is equal to 15, or A is equal to 3. Okay, so in other words, the radii of these two circles is 3 and 15. So one small, tiny little baby guy, and then one big guy. So that's The baby guy has a radius of 3 and the big guy is 50. Okay, great. So we are asked the equation of each circle. So the equations then are x, so just plug it into the general one, x minus 15 squared plus y plus 15 squared is equal to 15 squared. And the other one is x minus 3 squared plus y plus 3 squared equals 3 squared. There are the two equations of the circles, and that is a pretty nice question. I think this year the line and the circle have been pretty handy and pretty nice. Yeah, that is the end of the question. So hope that worked out well for people who attempted it.